This section is on continuous probability distributions, but before we talk about those, I want to quickly review discrete versus continuous random variables. So a random variable is discrete when it has a finite or countable number of possible outcomes that can be listed. There are gaps between the outcomes. A random variable is continuous when it has an uncountable number of possible outcomes. There are no gaps between the outcomes, and it can be represented by an interval on a number line. So a continuous probability distribution represents the values a continuous random variable can assume. The graph of a continuous probability distribution is a curve. The probability is the area under the curve between two values, and the entire area under the curve is equal to 1. And it's 1 because that represents 100%. Let x equal the amount of time in minutes a postal clerk spends with their customer. The continuous probability distribution is graphed below. Use the graph to find the probability that a clerk spends 2 to 4 minutes with a randomly selected customer. So the probability is equal to the area under the curve from 2 to 4. And this is because we are looking at from 2 to 4 minutes. And this area is 0.34563. So the probability that the clerk spends 2 to 4 minutes with a randomly selected customer is 0.34563.